For this video, we're going to look at systems of nonlinear equations. So near the beginning of the semester, we looked at systems of linear equations, both in 2 and 3 variables. Now we're going to expand the equations we can look at to not just linear, but any of the equations we've seen all semester. We are going to restrict ourselves to 2 variables for these systems of nonlinear equations, but we could have quadratics, we could have conic sections in here, we could have exponential logarithmic functions in here. Any equations that we want can work. So let's start. Well, the 2 techniques we're going to use to handle this will be substitution and elimination. We are not going to try to put things into a matrix again because those matrices really work well for linear equations, but they struggle a bit more when we play with nonlinear systems. So, let's look at an example. For example, we could have the system x plus y equals 2 and y equals x squared minus 4. So as we did when we had systems of 2 equations and 2 variables that were linear systems, we looked for an ordered pair that would make the system true, that would make both equations in the system true. And we would usually find either 0, 1, or we could find an infinite number. They could be dependent systems, or dependent equations, a dependent system. Here, we could see a lot more variation on this. Because this first one, x plus y equals 2, that's going to give us a line. That's a linear equation. But y equals x squared minus 4, that's a quadratic equation. That's going to give us a parabola. And a line could cross a parabola at 0, 1, or 2 points, but it can't do more than that. So 0, 1, or 2 is the only possibilities we have here. We will have 0 ordered pairs that work, 1 ordered pair, or 2 ordered pairs. And how are we going to find that? Well, our choices are elimination or substitution. In this case, I would say substitution's a nice one because we already have the second equation solved for y, which means all we have to do is take this x squared minus 4, plug it in for y, and solve. So let's see what happens. If I use substitution, I'm going to take the x for my first one, and then instead of y, I'm going to put my x squared minus 4. And now I've got one equation, one variable, I can solve. These parentheses aren't really necessary, they are just showing me where the y went. They're just showing me where this went. And so I can ignore them and rearrange stuff. Rewrite this as x squared plus x. I've got a minus 4, but I've also got 2 on the other side. I need to have a 0 on the other side, so I'll subtract the 2 and we get minus 6 equals 0. Which now means I can factor this into, what's that going to be? X plus 3 times x minus 2 is equal to 0. So we get x is negative 3, or x is 2. Awesome. But is that my solution? No, I need an ordered pair. So I need to figure out what the y values would be here. And here's the nice thing, I could try either equation. Let's go with that first one, it's a little bit simpler. So when x is negative 3, I would have negative 3 plus y equals 2. Add 3 to both sides, I get y equals 5. So one of my ordered pairs will be negative 3, 5. And that's one of my solutions. Oh, that's going to be a problem. when x is 2, I can plug that back in, and we have 2 plus y is equal to 2. Subtract 2 from both sides, we get y equals 0. So I also have the solution 2, 0. And these should both be solutions. To test, let's plug them into y equals x squared minus 4. So if I've got -3 squared is 9, minus 4 is in fact 5. If I come down here to 2, 2 squared is 4, minus 4 is 0. So this works as 2 solutions. So let's try something else. Notice in this case I could have done elimination. If I had wanted to subtract the functions from each other, I could eliminate the y, and I would get very close to this one. Good idea to practice that. I'm not going to go through it. One of the things that's going to be tricky, though, about systems of nonlinear equations is that we won't always get our choice. We will sometimes be forced to use either substitution or elimination because we won't be able to do the other one. How so? Let's look at another example. We will look at the system of equations x squared plus y squared is equal to 25. Recall from way back at the beginning of the semester, that's a circle of radius 25 centered at the origin. And then x minus y is equal to 1. And again, that's just a line. Here I can't eliminate any variables because if I try to subtract the equations, x squared minus x is still just x squared minus x. We don't lose the x. I add them, y squared minus y, or plus a negative y, is still just y squared minus y. I don't lose the variable, so I can't finish this one by elimination. I'm going to have to use substitution. So we'll go with substitution again. In my recommendation, that x will be really easy to solve for. I add the y over and we've got it. So this equation becomes x is equal to y plus 1. I can plug that in up here and have a new equation. So replace the x with y plus 1. Square this. Subtract the 25 over and let's combine the y squareds. So we've got 2y squared plus 2y minus 24 equals 0. First thing for factoring is let's factor out the common factor. Oh, but there's a 0 on this side, so instead of factoring it out, let's divide everything by 2. We've got y squared plus y minus 12 equals 0, which should factor into y plus 4 times y minus 3, which gives us 2 values for y, and now we need to find x. Okay. Oh, and now here we have to be very careful. We've got a circle and a line. If I plug my y values back into that circle, for each y value I'm going to get 2 x values. But is that line going to go through both of those x values? No, it won't go through both of those points. Sorry, I said that wrong. It will not go through both of those points. It will only go through one point or the other. So we're going to want to substitute into the line. This will make it sure that what we get is what we're looking for. So if y is equal to -4, Then I have x minus a negative 4 equals 1. Minus a negative 4 is the same thing as plus 4. Subtract 4 from each side, we get x is negative 3. So we have the ordered pair negative 3, negative 4. Now if y is 3, we'd have x minus 3 is equal to 1. Add 3 to both sides, x is equal to 4. So we have the ordered pair for 3. And now we can double check both of these. Negative 3 squared is 9. Negative 4 squared is 16. 9 plus 16 is 25. Negative 3 minus a negative 4 is going to be 1. Awesome. Try this one. 4 squared is 16. 3 squared is 9. They add to 25. 4 minus 3 is 1. That works. And here, of course, is the problem. If I had tried, let's do this right over here, with y equals negative 4. If I had tried plugging it into this one, x squared plus negative 4 squared equals 25. Negative 4 squared is 16, so that's x squared plus 16 equals 25. Subtract 16, x squared equals 9, which means x is plus or minus 3, which should give me the ordered pairs 3, negative 4, and negative 3, negative 4. So why is that one not good? Let's try plugging it into the line. I plug it into the line. 3 in for x, negative 4 for y. So 3 minus a negative 4, minus a negative 4, that's plus 4. That's 3 plus 4 is not 1. So when finding the second value, it's very important that we look carefully at which equation could give us false answers and which equation will be less likely to do that. It's also probably a good idea to go ahead and double check, just in case you chose the wrong equation to work with. If we double check, we would know, throw this answer out because it doesn't work. Okay, I'm running low on time here, so I'm just going to give us one more system and talk through the basics of it. How about this? We're going to go with the system x squared plus y squared is equal to 13. Ooh, a circle radius square root 13? Yeah, no problem. X squared minus y squared is equal to 5. What shape's that going to give us? That's a hyperbola. So let's think about it. A circle and a hyperbola, we might well have 4 solutions. We might have only 2, we might have none, we might have 1. There's a variety. There's a variety of options. We could even have 3 in theory. Unlikely, since the centers of these are the same, I'd expect anything to be symmetric. Any one point that happens is going to have a symmetric point. And in this case, I would say substitution actually might not be bad, but you'd have to be tricky about it. I would go with elimination, because what happens if we just plain add these 2 equations? Well, we've got x squared plus x squared is 2x squared. Y squared minus y squared is 0. And 13 plus 5 is 18. Divide by 2, get x squared is 9. And so x is plus or minus 3. And then we take each one of positive 3 and negative 3, plug them back in, pick one of these. It probably won't matter which one. Find your y values that match up with it. You should probably get 2 y values for each one. You might not, but you should watch out for that. And then test it in whichever equation you didn't do. So if you plug them into this to start with, test it in here. If you plugged it into here, test it in here. Whichever one gets you what you're looking for, well, make sure to test, make sure you don't have false solutions, and you've got your solutions. Thank you for watching.